Alright, so I was trying to do the live stream video, but I wasn't working out, so I'll just do a video here. So in regards to the notes, the cube, which some person might be familiar with already, is made of 6 squares. It's made of 6 squares. So this is a rough sketch of a cube, not drawn to scale. So you have the bottom square, top square, front square, back square, and the 2 sides. So that's 6 squares. So we know the area for a square is length times length, which is going to be L squared, because we remember from indices law, if you have L to the 1 times L to the 1, it's the same base, so we can add the powers. So that's why we have L squared. Next, we know that there's going to be 6 squares, so therefore, because you have 6 squares, so the area for a cube is going to be equal to 6 times L squared. So that's for the cube. For the cuboid now, the cuboid is a bit different. I'm going to draw it the same way, but don't be confused, it's not made of squares, it's made of rectangles in a sense. Let me see if I can differentiate it. So this is our cuboid, so it's made of rectangles. So now the difference between this cuboid here and the square is that we're going to identify it as this side, we're going to call it the height, we're going to call this side here, we're going to call it the length, and then we're going to call this side here as the width. So we have a height, we have a length, and we have a width. So if you realize it's made up of all rectangles, so we are able to find the area of the cuboid if we know how to find the area of a rectangle. And the area of the rectangle is given by length times width. So now, similar to the cuboid, we have 6 faces. Similar to the cube, we have 6 faces. But the difference is that the 6 faces are not equal. So we're going to identify the pairing as in which faces are equal. So that's the first thing we're going to do before we solve. So looking at the cuboid, we can see the bottom and the top are the same. So for the same, we have bottom and top. So whatever the area is for the bottom, that's the area for the top. Then we have the front and the back. So the front and the back are the same. So plus front and back. So whatever the area of the front is the area that the back is, the area that the back has. And then now for the sides, 2 sides are the same. So side plus side. So the 2 side, the area for this side over, so the area for this side is the same as the area for this side. So you can call it left or right side, but just know that the sides are going to have the same area. The bottom and the top have the same area, as well as the front and the back. So what is the area of the top? So this is our top. The top is this rectangular piece. So we realize that the top is given by length times width. So for the top, it's going to be length times width for the area, and it's going to be 2 times that because we know it's for the bottom and the top. So now looking at the front, we're going to look at the front. What is the area for the front? So we know that the height is going to be the same all around the cube. So therefore, the area for the front piece is going to be the height multiplied by the length. So it's going to be the height times the length. So front and back. So we're doing the front. So it's going to be height times the length, and we're timesing by 2 because we know if that's the area of the front, it's also the area for the back. So now we're going to look at the sides. So the sides now, this is a side over here and this is a side over here. So for the sides, we see here that we have the height and we also have the width. So we know the area for the side. So the side is going to be the height times the width, and we times it by 2 because there's two sides.